Okay, so the one-step equations, like I said before, inverse, or like Alex said before, inverse operation just means opposite operation. So when we're talking about opposite operations, we're talking about the process of undoing something, the reverse operation. Okay, so who can raise their hand and tell me what is the inverse to addition? What is the inverse to addition, Justin? Subtraction. So the opposite of addition, or the inverse of addition, is going to be subtraction. And basically that means if I take a number, like we'll say 10, if I take 10 and I add a 2 to it, and then I subtract a 2 from it, then what's my answer going to be? Just 10. It's like I didn't do this at all. Adding 2 and then subtracting 2, it's like it never even happened. What about the inverse? That in this sense creates a zero pair, but we're not really talking about zero pairs, because like multiplication, it's not a zero pair, is it? There's a multiplicative inverse. But what's the inverse of multiplication? Division. Good. So the inverse for multiplication is going to be division. So the same thing goes again. If I take 10 and I multiply it by 2, but then I go and divide it by 2, what am I going to get? 10. Okay, multiply by 2, I get 20. Divide that by 2, I'm right back at 10 again. So it's almost like these never happened. They are inverse operations. They are going to undo each other's effects. Now, again, you should have already seen simple one-step equations last year, so we're just going to do a couple quick little practices, and then we're going to focus on word problems. That's the important part. So if I have x minus 8 is equal to 7, and I need to solve for x, what inverse operation am I going to perform to get x isolated by itself, JD? Well, right now we see subtraction. So what's the inverse of subtraction? Addition. So now we're going to go ahead and we're going to add. Now notice I'm putting an addition sign on both sides of my equal sign. It's because I need to not only add 8 to undo that subtraction of 8, right? I want to make sure that when I subtracted 8, I'm undoing its effect. So now I'm adding 8. Not only am I going to put it here, but I also have to put it on the other side. Why is that? Why do I have to put an addition of 8 on both sides? What's the purpose of that? I mean, if I put that I'm adding 8, does that mean x is going to equal 7? No. Okay, because if I just said, oh, I'm going to add 8 here and get rid of it, I'm not really looking at the same value anymore. I'm not keeping it balanced. That's a key word to understand. You have to have a balanced effect in order for there not to be any adverse changes. Okay, you need to keep things fair. It's kind of like how many of you have a sibling? All right, so Mia, you've got a sibling. So let's say everything's going great. You and your siblings, you both are on your best behavior. You guys are good. Mom's going to go ahead and give your sibling $10 for great behavior. Don't you think you'd want $10 too? Yes, because it's keeping it balanced. You have the exact same behavior as your sibling. You expect to have the same results or the same reward given. It's the same thing here. Hey, I'm giving 8 to one side of my equation. My other side wants it to stay fair. It wants it to stay balanced and equal. So I have to do it to the other side as well. So every time that we're working this out, the key thing that I need to make sure you say is that you're going to do this to both sides. And what do I mean by sides? Sides of what? Where's my cutoff, my wall that creates one side of the equation and the other side of the equation? What is that? The equal sign. The equal sign creates that division, that wall there, that whatever I do to one side, I have to do to the other. So if I'm adding 8 here, I have to add 8 on the other side as well to keep it balanced. Now again, we just said before, if we subtracted 8 and then added 8, it's almost like it never existed, right? So I can put a box around it and cross that off. It never was there. So my x is going to come straight down. X is by itself. It's all on its lonesome, and I know what it equals. What will x equal? 15. 7 plus that 8 is going to equal 15. And then you can check it. You can take 15 and substitute it back in. What's 15 minus 8? 7. So as long as you've solved it correctly, when you take your answer and substitute it or evaluate it into the expression, it should work. It should come out to the correct expression, okay? Let's take a look at the next page. So go on to page 44. I have 1/2 m is equal to 20. 1/2 m is equal to 20. So what operation do we currently see? What operation do we currently see? Not what inverse, but what operation is existing between 1/2 and m? Mia? It's not division. When they're side by side, it's multiplication. Good. This is currently multiplication. So what is the inverse that we have to perform? Division. All right? So now again, like I said, the key thing that you need to write is that you're going to divide on both sides. So we're going to divide both sides by what? By 1/2. Good. We want to get the variable by itself. So if I want to get the variable by itself, I've got to get rid of whatever's paired with it. So I'm dividing both sides by the 1/2. So I'm taking a 1/2 and dividing it by a 1/2. I'm taking 20 and dividing it by a 1/2. Okay, so multiplying by a 1/2 and then dividing by a 1/2, it's like that never existed. I can cross it off. Then I need to put m down here. M is now by itself. It's isolated. Sirius, turn around. What is 20 divided by a 1/2? Kingston? 40. 20 divided by a 1/2 is 40. And now if you want to check, substitute it back in to see if it's true. What's 1/2 of 40? 20. 1/2 of 40 is 20. All right. We've got 108 is equal to negative 9y. 108 is equal to negative 9y. What is the inverse operation that I have to do to both sides in order to get y by itself? Julian? Division. Very good. Right now, this is multiplication, isn't it? Please stop throwing the paper. Right now, this is multiplication. So the inverse operation is going to be division. So we're going to divide both sides by negative 9. You need to make sure you're including that negative because you want y by itself. If you don't divide by the negative, then the negative is going to stay with the y. But you want y completely isolated. So we're going to divide both sides by negative 9. Why did I put a fraction bar? It's a division problem, right? Fractions are division problems. Numerator divided by denominator. A fraction bar is what you're more commonly going to see. I want to make sure you guys understand that. That when you put a little fraction bar, that means you are dividing. We are dividing both sides here by negative 9. Okay, what's 108 divided by negative 9? Negative 12. Good. So you could write it as negative 12 is equal to y, Or if you wanted to put the y first, you could put y is equal to negative 12. Either one of those is perfectly fine. Those 9s will cancel out, right? They're going to cross off. All right, I want you guys to try these 4 on your own. All right, who can raise their hand, tell me what they got for problem number 4? X plus 3/4 is equal to negative 2/9. What is X going to be equal to? Mia? Very good. Negative 35 over 36 is the correct answer. This was an addition problem, so the inverse of addition is to subtract. So you want to make sure you're identifying that you are going to subtract 3/4 from both sides. So we're subtracting 3/4 here and subtracting 3/4 here. And that's going to give us X is now equal to negative 35 over 36. Negative 35 over 36. All right, what about for problem 5? What does X equal for problem 5? Kingston? Ooh, not quite. It's not 17. Evelyn? X equals 13. What's the inverse operation here? Addition. So we need to add a negative 2 to both sides. We're going to add negative 2 to both sides. Right now we're subtracting a negative 2, so we want to do the inverse operation. So that means the only thing that's the opposite is the operation. We're going to add negative 2 to both sides and add a negative 2 to the 15. Once we do that, we're going to get X is equal to positive 13. So we're adding negative 2 to both sides. Okay, for problem number 6, what is the value for B? What does B need to equal? Come on, guys. What's the inverse operation here? Multiplication. So we're going to multiply both sides by what? -3. What would we get? Not -12, but +12. Negative times a negative is going to give you a positive. You need to multiply both sides by -3. You're multiplying both sides by -3. So if I multiply and divide by -3, it's like it never happened. Okay, and if I multiply -4 times -3, then I'm going to get a positive. So I get a positive 12. 4 times 3 is 12. What's the inverse operation for number 7? Kristen? Division. Very good. So we're going to divide both sides by what? 17. And what's -85 divided by 17? -5. -85 divided by 17 is going to give you a -5. Don't forget, you're dividing both sides by 17, so those 17s will cancel out. W is going to be equal to -5. Please make sure you're using your calculators to double check your multiplication, division, addition, and subtraction, okay? All right, let's go on. We're going to go to page 45, and we're going to do some word problem practice. Yeah. Huh? Divide -85 by 17. You thought you needed to divide both sides by 85? No, you want to get the variable isolated. So you're looking at what right now is currently attached with the variable. Yeah. It's just opposite operations. I see addition, I need to do subtraction. If I see division, I need to do multiplication. Then I'm going to have to set you up on an IXL to do it, because this is something that we learned last year. Then I'll have to set you up on an IXL. I can't sit here and reteach you everything from last year and then do this year's stuff. This is something you guys already learned. It's just a recap. Yeah. Whatever's attached to the variable. Whatever's on the same side as the variable, that's what you're focusing on. Okay? If it's on the same side as your variable, then you focus on working on that. Yes. What part? Like, what do you mean? Well, if you're looking at a multiplication problem, you have to divide. If you're looking at a division problem, you have to multiply. It's the same thing. Like, I know if I'm looking at addition, I have to subtract. So if I'm looking at division, I have to multiply. Okay? All right. Some word problem practice. What do you think? Last year, Tiff practiced piano. A total of 700 hours. This was twice as much as what she practiced this year. How much has she practiced this year? Okay, so this is the word's problem. So it's kind of like the same idea as the equation. In the equation, they're visibly telling you an operation, and you have to do the opposite. In a word problem, they also tell you an operation, and you have to do the opposite. So right now, what's the word problem's operation? What operation do we see currently in this setup? Multiplication. How do you know? Twice. Very good. The key word twice means that it's a multiplication problem. So basically, if I were to simplify this entire word problem into just a little statement, that statement would be, last year was twice this year. Last year was twice this year. Does that make sense? Now, all I have to do is plug in the information that I do know. Do I know last year's amount? Yes. Yeah, right? I know last year's amount. It says it right here. It says it's 700. Last year was 700 hours. So I can replace the value of last year with 700. Now, the key word was, up at the very top, I want you to write this following information. The words is, was, and are means equals. When you see those words, this is, this was, these are, that means that this is an equal sign. So the term was is going to be my equal sign. It's not an operation, it's an equal sign. And then just like JD said, twice means it's multiplication. But do I know this year's amount based off of the word problem? Before I do anything, did the word problem tell me this year's amount? No, it doesn't give me a number for this year. So what do we put? Huh? Y, H, X, a variable. You put a variable. Okay, so we know it's multiplication, so I'm going to write it as 2H. I'm actually going to go ahead and write H because that makes sense. It's hours, right? So there's my equation. Nope. There's my equation. Now I need to do the opposite. So in the problem, I knew I had to multiply, but I need to do the opposite. The problem is multiplication. The opposite is what? Division. So we're going to go ahead and divide. I'm going to divide both sides by 2. And how much did we practice this year? 350. So this year, Tiff practiced 350. So if you can figure out the problem that's given to you in the words, then do the opposite to it. So if you know that the word problem is a multiplication problem, do the opposite, and that'll give you your answer. Let's take a look at another one. Last week, Liz worked 36 hours. This was 2 hours more than this week. How many hours did she work this week? So again, figure out what the operation is in the problem, and then you do the opposite of it. This week, Liz worked 36 hours, last week. This was 2 hours more than this week. How many hours did she work this week? What operation is the word problem describing? Addition, right. How do we know it's addition? More than. Okay, right off the bat, the term more than means it's going to be an addition problem. I like to go ahead and just simplify it into one simple statement. Last week was 2 more than this week. Last week was 2 more than this week. How much did she work last week? How much did she work last week? 36 hours. It says it right here. Last week, it was 36 hours. Remember, the term was is our equal sign. And then 2 more than this week means take this week's amount and add 2 to it. Take this week's amount and add 2. That's what 2 more than this week means. So what operation is my inverse? Subtraction. We're going to subtract. We're going to subtract 2 from both sides. How much did she work this week? 34 hours. So Liz worked 34 hours this week. Okay, so I'm going to go ahead. You guys, I want to make sure you have plenty of time to work on your assignment today. So that's 22 minutes to be able to get onto your assignment today. You need to make sure you complete the whole thing. If it's not completed in class, where does it have to be completed at? Home. Okay? It looks long because the first few problems are just solving the equations. Here it is. Okay? But these should be quick because you just have to do opposites, right? Okay, what's my opposite here? Minus. What's the opposite here? What's the opposite here? What's the opposite here? No, division. Division. What's the opposite here? Multiplication. So you're just doing opposites throughout all of these to solve. Then you're going to get to the few word problems. That's where you need to create. You have to write an equation and then solve the equation. You have to know how to write it and solve it. So do like what I did. Piece the situation together as a statement, as a single sentenced statement, and then translate it into this equation, okay? This shouldn't take you much time right here. This should be quick. If you would like, which is probably a very good preferred method, have a separate sheet of paper that you attach and you do your work on that paper, so that on here, the only thing that is on here would be your answers. So that way it's easier when we check it, it's faster. We're not having to look through all your work to find your answers. Okay? All right, let me get them out to you.